Good evening. Welcome to the second episode of Let's Talk Weather, the Weather Channel in India's novel attempt to drive conversations around weather events that affects our lives on a day-to-day basis. Today's session is one of the most interesting sessions that we have in this series. It's of course on the ongoing season, the Monsoon 2020. I am Dikshit Pinto, and for today's session, we have with us some brilliant meteorologists and weather scientists from across the world. Let me introduce you to the panel. Dr. Sridhar Balasubramaniam. He is an associate professor in the Department of Mechanical Engineering and an associate faculty in IDP Climate Studies, IIT Bombay. Welcome, Dr. Sridhar. Professor Raghu Murthugude. He is a professor of atmospheric and oceanic sciences and earth system sciences at the University of Maryland, USA. Welcome, Professor Raghu.
Thank you, Dikshit. Hello, everybody.
Hi, Raghu.
And we have Akshay Dioras. He is an independent meteorologist and a researcher at the Department of Meteorology at the University of Reading, UK. Welcome, Akshay.
Thank you, Dikshit. Hi, everyone.
Hi.
Thank you all the experts for agreeing to be a part of this timely conversation on Indian monsoons. Not many of us like summers in India. Sunny skies, brown lands, and sultry surroundings. But as the pages of the calendar turns and monsoon slowly slithers in, a wave of freshness sweeps the rich and diverse landscapes of India. Skies turn green, skies turn dark, lands turn green, and surroundings become wet. For me, monsoon reminds my childhood. Chai and pakoras, the smell of the native land. Nobody can match that. For others, monsoon means something else, a hope for a farmer, an inspiration for an artist, and just a dance for a child. More importantly, it means something for everyone in this subcontinent. Kushwant Singh once wrote, "To know India and her people, one has to know the monsoon." So let's start from the basics. Sridhar, if you can explain us in a nutshell, what is Southwest monsoon and how significant it is as a weather phenomenon for Indian landscapes?
Yeah, in a nutshell, it's going to be very hard, but I'll try my best. So the Southwest monsoon, as I understand, is a synoptic scale weather pattern that brings rain to many parts of India and also parts of South Asian countries. It basically signifies a change in the wind pattern, which at lower levels of atmosphere, which during the monsoon months blow from west or southwest towards the east, as opposed to other months where the winds are east to west. So this is one of the most significant features of monsoon. And along with this, it also brings along a monsoon trough, which is nothing but a belt of low pressure region. And it extends all the way from the Bay of Bengal to Rajasthan, also covering the central parts of India. So monsoon trough is basically a system which engulfs both the monsoon circulation as well as the intertropical convergence zone, which is also abbreviated as IPCZ. The monsoon trough is the region where the winds meet. So south of monsoon trough, the winds are westerlies, which is west to east, and north of monsoon trough, the winds are east to west. So trough is the region where the winds meet, and that is also the region where your cyclonic vorticity is produced, leading to formation of these low pressure systems or monsoon systems, which are known to give rain. And the formation of westerlies and monsoon troughs is a direct result of something known as the Mascaron High, which is the high pressure region near the Mascaron Island, which usually forms in April. And along with that, the Tibetan plateau heats up, resulting in a low pressure system over land. And along with the Coriolis force, the winds are pushed from the Mascaron Islands towards Somalia and all the way to India through this low-lying jet, which we call as Somali jet. So the Somali jet brings in a lot of moisture from ocean to land, giving abundant rainfall to many places in India. At the same time, what happens is the monsoon trough also starts moving from the equator towards north. And as I already said, the monsoon trough is the system which leads to convergence and also production of cyclonic vorticity. So it helps in a lot of development of systems over Bay of Bengal. And these systems result in heavy rainfall over many parts of India, because as the low pressure system forms in either Arabian Sea or Bay of Bengal, they move along the axis of the monsoon trough, thereby covering different parts of India and giving rain. So this is in nutshell, as I understand the monsoon dynamics and how it affects India and how it is a very important feature for the Indian subcontinent.
Thanks, Professor. Amid the COVID-19 pandemic, there was a lot of anxiety on how monsoon will play out this year amid all the economic distress that the country is going through. The onset and performance of monsoon is something that many economists, many policymakers and farmers and across the country, everyone was worried about. As the onset approached, the forecast dates started fluctuating and eventually monsoon did arrive right on time. However, the onset of monsoon every year, the forecasting onset of monsoon is a very complex task. It's riddled with uncertainties, multiple factors, even the smallest factors like pollution and the local winds and cyclone formation, everything affects the onset of monsoon. Raghu, if you can shed some light on some of these lesser known intricacies of monsoon onset, that would help our audience a lot.
Yeah, great. So you mentioned how farmers look forward to the onset and artists get inspired and everybody looks forward to the monsoon. But obviously monsoon scientists start worrying about the monsoon onset in what we call pre-monsoon season, which starts in March, April, May. And the trough that Sridhar mentioned actually doesn't just move from the equator. It actually starts way over on the Western Pacific and moves northwestward over South China Sea, Burma, Thailand, and so on into the Bay of Bengal. And the conditions that set up the southwesterly, it's not just an screen high, but you have the ocean that's warming slower than land. So land warms faster as the sun moves across the equator over to the north, and the low pressure created by the land warming and the high pressure with the slower warming on the ocean begin to set up winds from the high pressure to low pressure, so from the ocean onto land. There you add the rotational effect, what Sridhar referred to as the Coriolis force, which gives you the southwesterly flow coming on from the Arabian Sea, Eastern African coast towards India. The trough that's moving northwestward from South China Sea towards the Bay of Bengal is happening from April onwards. And various factors affect how quickly it moves. So if you pull up that temperature plot that I had sent you, which is showing the pre-monsoon temperature anomalies over the entire globe. And you can see that the big news at the time was that all the pollution was going down because the lockdowns were rolling around, starting in China, in Italy, Spain, and so on. So pollution was being reduced, oceans were getting cleaner, everybody was reporting how many animals were being seen where and so on. And in general, when you reduce pollution, you expect that the land that is not seeing as much sun with the pollution will see more sun and will get heated more. So people expected maybe that'll accelerate the monsoon arrival and so on. But actually this pattern here shows the very prominent Siberian warming that was discussed a lot. There is a prominent cooling over India, which is unusual because there was cleaner air, but you are getting cooler temperatures, basically because you had the entire global circulation responding to the cleaner air, and the Siberian warming, which is related to the Arctic warming, and the jet stream, the so-called polar jet stream wiggling, which you can see as cold, warm, cold patterns over US, North Atlantic, and Siberia. This actually created another kind of a process where the so-called Western disturbances that arrive in the winter and spring months actually arrived in larger numbers. So this set up a lot of pre-monsoon rainfall over not just North India, Central India, but also over Pakistan, Iran, and Afghanistan and so on. And that's what led to the locust problem that we had discussed. But coming back to the monsoon onset, the land being cold and the ocean, Indian Ocean especially being warm, actually you expect the onset to be delayed. And this is what I was talking about before the monsoon onset, that I would expect a delayed monsoon onset. And even IMD was saying the onset could happen in. But two things happened. The cyclone Amphan came along and pulled the monsoon trough over Andaman Islands, and the monsoon over the Andaman happened in mid-May on time. And then Nisarga came along, and actually the monsoon trough got pulled onto India, and the onset happened early on. So we can return to the impacts of these early or on-time onset, unexpected on-time onset, despite these unfavorable conditions as we go a little more into the discussion. But this onset, which is something that farmers look forward to, doesn't always necessarily correspond to how much seasonal rain you will get, but it is something that is so dramatic and does indicate the progression of the monsoon trough all the way to the Himalayan foothills. So we look forward to it. So this year has given us some very strange combinations of the pollution being reduced, cyclones pulling the trough, and creating a monsoon onset on time.
If I can quickly add to what Raghu has said, because this is a very interesting point. If you see this figure, there is a cold blob there over North Central India, Northern India, specifically over Tibetan Plateau. So what happened was, when we were seeing this thing in the beginning, around March or April, and there was a prominent blob over the Tibetan Plateau. So that's something also was a bit of a concern, because cooling over Tibetan Plateau does tend to influence the first half of the monsoon season. And that was happening because we got a lot of Western disturbances, but it turned out that somewhere around mid-May or after mid-May is when we are having transitions. So Western disturbances move northwards, you get heat waves. So all the missing heating starts again, heat low builds up, and that somehow pulls the monsoon on time. So interesting.
Interesting. Akshay, if you could shed some more light on the overall patterns that had the overall interplay in June and July. How in Mumbai, especially if you see, July was one of the wettest for Mumbai, but still Mumbaikas didn't feel that it rained a lot, especially the suburb, the catchment areas didn't get much rain. Why such dynamics happened? What was the peculiar thing about the monsoon 2020 that you have been observing?
Yeah, so I would first start by saying that the most interesting feature, not just for me, but for all, is that the monsoon came on time, because it did not really self-isolate or self-quarantine itself during the lockdown. I mean, we all have been locked down, we all have postponed our plans, canceled our plans, but the monsoon came on time, so we should be all grateful to it. I would say that, first coming to the point that you have asked about Mumbai. So in the beginning, you mentioned about chai pakoda. So I would say chai pakodas and bhutta. So that have been missing this time, because if you see the timing of precipitation in Mumbai, so it's mostly happening after the evening, sometime early morning and so on, because it's a clear classic battle between human perception and statistics. So if you see statistics, the city has got a lot of rainfall. So until now, or I can say around the end of July, more than 85% of the annual rainfall, of the seasonal rainfall was already there. And then you had more number of rainy days in July. There were some sort of more heavy rainfall events, like more than 150 millimeters, 200 millimeters, and so on. So everything is fine statistically. I mean, the region has got more than 2,000 millimeters so far. But then, like you said, what was missing? So I would say we had got more thunder showers, which were like more skewed towards, I would say, the evening part, and that's the time when most of us are sleeping. So if something like this happens during the daytime, you tend to notice the rainfall quite a lot, just like it's happening today. It's raining across throughout the day in Mumbai. But if you see this 3rd to 4th August rainfall a day before, so that entire massive, 250 millimeters, 300 millimeters rainfall happened over the night. So that's where people are sleeping. And that's something that we have to really consider, because our models don't really capture the timing of precipitation that well. So when you have got a warning that goes on for 24 hours, but if you get that much rainfall in just a few hours, and that too also sometime, let's say early morning or sometime late night, then that also creates problem. You also asked about some more things which are about this year's monsoon. I would say another interesting thing is that we have not seen any strong monsoon low pressure system over the Bay of Bengal so far. Of course, there is one right now which is forming. This is, I won't say very unusual, because we have had some years, like last year was also a similar case when we did not get a strong monsoon low pressure system, what we call as monsoon depression. There have been a few years in the past, maybe 2002, 10, 12, that's what the IMD claims, but there are some research where people have challenged that. But that is really a clear feature, because when you look at the rainfall that was there in July, so these monsoon low pressure systems, like Sridhar was talking in the beginning, so they form over the northern parts of Bay of Bengal, most of them, from where they propagate inwards towards India. And central India as well as East India is a crucial region where they dump quite a lot of rainfall. So when you look at June rainfall, you see a massive deficit over that region. And that's really interesting. So I think that's probably answer.
I'm correct. I want to correct a couple of misstatements maybe. The rainfall, you can pull up my second plot of the IMD rain deficit, if you can. We actually, the total rainfall for the one that shows the rain thus far, cumulative rainfall. Yeah, this one. So the total rainfall over Mumbai west coast tends to be around 2,000 millimeters. We are only at the end of July into August, so we are nowhere near 2,000 millimeters. Plus, you can see that the left panel is the accumulated rain thus far. The middle one is what you would expect normal by this time. This is up to the 3rd of August. I looked at it this morning, including the rainfall on the 4th. The difference doesn't change much. But the right one shows you the difference between what we would expect and what has happened. And you can see the red along the entire west coast, except in the middle northern Karnataka. The rainfall actually has been quite deficit. So the rainfall is actually expected to be around 1,000 millimeters by now. And it is somewhere around 500 to 800. So there is a deficit all along the coast. And this goes to the point I would again come back to later, that the deficit pattern in the right panel actually shows that the cyclone that pulled the trough on time has dumped a lot of the rain, and there have been some northeast floods with some blue and red patterns. So the entire monsoon circulation is weaker, which is the only way you can get weaker rainfall on the west coast, because the southwesterly winds are weak and they are not bringing enough moisture onto the Western Ghats and dumping rain. The other part is, of course, the depressions or monsoon lows that I mentioned, and that is related to the central eastern part. But in general, the trough is weaker, the monsoon circulation is weaker. The monsoon depressions and lows don't really affect the west coast as such. So the west coast deficit is definitely there, and it's not really so much to do with when the rain fell. People are noticing that there is a deficit rainfall, and the deficit over the west coast is in the 20 to 30% range.
Just one more interesting thing that I observed was that the monsoon trough actually moved, once it set in, it moved very rapidly. And that was one of the reasons why I think in June, Mumbai missed out on good rains, because the trough almost moved. Yeah, the trough almost moved very rapidly to the North India, and thereby triggering floods in the Northeast and Bihar. Because once the trough moves there, then you have a lot of rain in the Northeast India.
No, even if the trough moves a little bit ahead of time, which it did, because there was another depression over the northern bay in the second week of June, which pulled it forward. But if the monsoon circulation is weak, then the coastal rainfall is weak. The trough doesn't have direct effect on the west coast rainfall. So it is the circulation that is really weak. And that is related to the cold land and warm ocean that I mentioned before.
But perhaps that also could be related to, if you see this 850 wind anomalies that is in the lower troposphere, that too across June and July, So we do have these easterly anomalies that are all coming from the Pacific, so from West-North Pacific towards from dateline. So we still have, of course, we don't really have a full-blown La Nina as of now, but the patterns look similar to that. And they have been there, so your point is correct that we do have a weakened monsoon circulation so far. But if you see the rainfall in June, that was about what, 18% above average? So intense convective.
Only it was June overall was a deficit. July inched up to 10% above. But this is misleading. If you go back to that plot, you are averaging over regions which got excess rainfall by the cyclones. But monsoonal rain itself is pretty weak. So this averaging is always misleading, right? Look at the central core monsoon zone all the way to Kashmir. It's all red. So that is below normal by anywhere from 10 to 30%. So averaging over heavy rainfalls that happened because of Amphan and Nisarga and the depression in the second week that didn't have a name, you get seemingly excess rain. But the overall monsoon has been weak, and you can talk to farmers over many regions where rice didn't get enough rain on time and just wilted away.
So yes, this is something that many experts do agree that though the overall figures in June show that the monsoon rains were excess, in fact, both June and July were much drier for the parts that were expecting monsoon rains. So Raghu, if you can shed some more lights on this, the deficit is still there, where the forecast suggests that there will be a better August and September, and the deficit, that the makeup might happen. But what are the impacts or the negative consequences of the deficit in the initial 2 months?
Yes, so the crop selection obviously got heavily affected. People who were expecting good rain, especially because onset happened on time, you think rainfall will, and the trough moved earlier than expected. So people were expecting normal rain. So on the west coast near Mulshi Dam, when people lose rice because there was not enough rain, Ratnagiri and Dobruk and so on, where rainfall was below normal by more than 30% and the rice paddies didn't get enough rain, then you know there is a problem. The July, August June only contributes about 20% to the seasonal total. So it's just the crop selection that matters at that time. But if you don't get rain into July, then you have to start picking other crops, the second half of the crop, peppers, onions, beans, whatever else. And now the forecast is kind of seems to be saying that the August rainfall will recover. So again, remembering the patterns are important than the all-India average. The heavy rainfall over all along the coast of West Coast, from Kerala to Mumbai, shows that the monsoon circulation has picked up. And the other figure that I sent you, the animation of the Pacific SSTs, clearly shows that the sea surface temperature anomalies have been cold now for, so this is showing the sea surface temperature anomalies from June into July, first week of July. And you can see that this very cold wavy patterns, the waves are known as instability waves in the ocean and so on. This is typical of La Nina. And La Nina in general favors a good monsoon. And La Nina does affect the August and September rains more. So I would expect that the IMD is on the right track in terms of saying maybe August and September will be favorable, and also tends to delay sometimes the withdrawal, in which case, like last year, the withdrawal got delayed really by a lot. Happens, overall monsoon recovery will happen, but the farmers have already paid a price in many places for the deficit thus far.
A quick reminder for all those who are joining in late. We are having an exciting discussion on the monsoon season so far, the forecast, expectations, and the present status of Monsoon 2020. Moving on to the next topic, a rather unfortunate consequence of monsoon, floods. So we saw many urban floods happening in Delhi and Mumbai and many other parts of the country. but the major concern has remained the recurring floods in Bihar and Assam. So Sridhar, if you could share some thoughts on why these recurring floods happen in these parts of the country every year, and what is the role of monsoon trough here, and how does it affect the overall dynamics in this part of the country?
Yeah, Dikshit, I'll just share the screen because I just need to show a photo. So basically, this is the trough that we have been talking about. So you can see that it has a east-west extent as well as north-south extent, and most of the time the trough is positioned in this region, which is near the North Bay and going all the way up to West Rajasthan. That is the normal position of the trough. So as I already said, the trough brings in the westerly winds. So south of the trough, the winds are westerly, and north of it, the winds are easterly. So they meet and then they create a convergence. And at the same time, you have, since the circulation pattern that Raghu and Akshay have been talking about, there is the monsoon circulation is created due to the cyclonic vorticity, and that vorticity creates systems in Bay of Bengal which move towards the land. And during that part, what happens is that your west coast gets active and you have a lot of moisture convergence or moisture flux, and that's how the west coast gets a lot of rain. So this monsoon trough has a pattern. It moves north and south during the monsoon season. And sometimes it is also known as this monsoon intra-seasonal oscillation, because it doesn't stay at one location. It has a northward or southward journey. So the floods that happen during in Northeast India and Bihar is due to the reason that this trough moves up north from the normal position. So it goes and settles near the foothills of Himalayas. And when it is there, your convergence of winds is happening here, and your monsoon circulation is very active over this region, which encompasses Bihar and Northeast India. And during that time, you have very heavy rains in these regions when this trough moves and settles near the foothills of Himalaya. And the other thing is that you have a lot of rivers flowing in Bihar and Northeast India. You have almost like 10 or 12 major rivers in Bihar. And apart from that, you also have Nepal is a mountainous region which is very close to Bihar. And heavy rains in Nepal means that the flow is going to come down. So the heavy rains in Nepal also ensure that the water flows down through the rivers. And that's the reason why you have floods in Bihar most of the time, every season. That's one of the reasons why the flooding is very common. And Northeast India, you have the mighty Brahmaputra, which always overflows because of these heavy rains or very heavy rains. Northeast India is known to get these bursts of heavy rains. And usually this is, these regions have riverine floods. They don't have urban floods because they have a lot of rivers flowing through these regions. So the riverine flooding is very common, which leads to swelling of rivers, and that causes either dam breaks or many other ways in which you experience these floods. And those are quite dangerous because they can create a lot of damage. So while on that topic, I talked about this MISO. So if you want to understand this monsoon intra-seasonal oscillation, then the IITM Pune has a very nice chart which shows how the monsoon intra-seasonal oscillation moves. And it has different phases. So you have different quadrants. And when the monsoon axis is down south, then the peninsular India will get good rains. When it is near the normal position, then Mumbai and Gujarat get good rains. And as it moves towards the north, towards the foothills of Himalayas, then obviously you have flooding in Bihar and Northeast India. So looking at this chart, you can get an idea of how the monsoon trough, which encompasses the monsoon circulation and the convergence, how these things are moving, and you can kind of come to a conclusion where the trough is and when it is going to rain or flood in Bihar.
There's one more interesting thing about Bihar, if I just quickly add. So like Sridhar said, it's the region has got a lot of rivers. So about 76% of the population in Bihar lives in northern parts, and that is quite close to Nepal border. And we have 3 rivers over there. So it's Kosi, then we have Gandaki and Karnali. So these 3 rivers come from all the way from mountain regions in Nepal. So whenever you have heavy rainfall in Nepal, landslides as well. So you've got a lot of water that comes down, and sometimes these landslides even block the path of these rivers, and then they have to do some sort of blasting to open the channel, and that releases quite a lot of water, and that has happened in 2014. So it's a very persistent problem there.
I think other thing I would add is everything that Sridhar showed is kind of what happens normally anyways. This story cannot be completed without mentioning the extremes. So what is happening really is that as the land is warming and the air is warming, atmosphere acts like a sponge. So if you can imagine a sponge where you pour water, it just soaks up all the water. But if you push on it, then it wouldn't drizzle. It'll start pouring somewhere. That's kind of what is happening. So the monsoon extremes, we published a paper in 2015, which shows that the widespread floods have increased threefold in the last few decades. So the events large scale means more than 10,000 square kilometers size. They used to happen only about twice per year. Now they are happening almost 6 per year in frequency. So this is costing several $1 billion every year, which is part of this story. The other is that the extreme events are also kind of merging from, forcing from both the Bay of Bengal side and the Arabian Sea side, both of which are warming. So this confluence of warming from both sides pumping moisture, because when the land warms and it creates these instabilities that demand moisture, it cannot rain heavily unless the moisture is supplied from somewhere. So the moisture supply is really important, and the ocean warming is really pumping in these moistures and kind of fueling these very large scale extreme events. So even in terms of the MISOs or the active break cycles, you can see that the active cycles have become more intense. So the rain in those active periods is increased because of these extremes, and the break periods have become more frequent in the season, which means you're squeezing in more rain during the small intense rainfall periods. So all these together give you the floods. So nature gives us rain, but a lot of these land use changes and the slopes and the urbanization that give you floods. That's what creates these urban floods. The drainage systems are not designed for rainfall rates that we get, like 250 millimeters per day and so on.
Yeah, that is very true. The extremes have increased. I totally agree on that.
Okay, Sridhar, if you can share some more thoughts on the current Bay of Bengal low pressure, which is a remnant of the tropical storm that happened over Pacific. So how is it going to affect the entire Western coast is already seeing the effect of it. How is it going to impact the entire country?
Yeah, so so low pressure has already formed, and I think it has also it became a well-marked low as well, and it has started moving towards the land, and already has dumped a lot of rains in West Bengal and Odisha. So if I just pulled up this chart because this is the temperature anomaly chart, which is showing the temperatures which from normal, the departure in temperature from the normal. And throughout July, Bay of Bengal was kind of showing, it was not showing such high temperature anomalies. So this red is basically very high SST or very high ocean heat content in both the basins, Bay of Bengal as well as Arabian Sea. And that is one, I feel like that was one of the reasons why the system originated, because you can see that there is a warm pool of water which could have given a lot of convective power to the system, and help in creating a cyclonic vorticity. And your trough was also present at this particular location around this time, because if you look at the MISO plot, then the trough is positioned at central India, which is the normal position for the monsoon trough during this point of time. So what happens is, as this low pressure forms, then it will move along the axis of the trough. So this is the axis of the trough. Not exact, this is just a representation. It can move anywhere slightly above the line or below the line, but it will move along the axis of this trough. And as per the IMD forecast, this Bay of Bengal system is supposed to move towards central India, covering Madhya Pradesh, and then obviously it is going to, go to Gujarat. So that is the path that this particular system is going to take. And at the same time, it is going to weaken because the moisture pumping that was coming from the ocean is no longer that active once the system comes to the land. So it will weaken, and then, but then the interesting thing is that you also have this Arabian Sea, which has a system, kind of a cyclonic system in the North Arabian Sea that can also pump in the moisture. So as it comes towards Gujarat, then the system may kind of slightly intensify again, and so by tomorrow it will give a lot of rain to central parts of India, North Maharashtra, and also South Gujarat, and finally East and Central Gujarat. That is what is expected from this low pressure system before it kind of dissipates out by 7th of August. Early morning 7th of August, it will kind of disintegrate is what I feel.
I would just add, when this picture is up, that because the low pressure is so high up on the North Bay of Bengal, that's what pulls the southwesterly winds towards the northeast. If you have a low pressure towards the southern Bay of Bengal, then actually the southwesterly winds become much more westerly and zonal. Then you tend to get very heavy rain over Kerala and not over Mumbai. So this pull from the Bay of Bengal depression or low pressure system is interesting because it creates a moisture demand on land in different places, and the supply, because of the southwesterly winds, moves accordingly. So the low pressure being so far north over the Bay of Bengal is actually giving you a southwesterly flow that is going more towards the northeast. And that's what is creating these heavy rains over Mumbai, Gujarat, and inward.
And that's the reason why we expect that the North Konkan or the interiors will get some good rains, and catchment areas will kind of have some good inflow. So let's see.
We also have development of low-level vortex over there, or northern Arabian Sea, which is also a big factor over there. If I can just quickly come back to the northeastern floods from this figure. So quite clearly, we haven't seen any strong monsoon depression, which, if you have some strong depression, let's say over the North Bay of Bengal, and when it starts moving west-northwest, it pulls the trough. But this time, like I said, we have got many weaker low pressure areas or weaker low pressure systems. So that was sufficient enough to keep the trough close to foothills, but it also provided what is known as cyclonic vorticity, and that also played a big role in amplifying rainfall over Bihar and Northeast. I would expect if we have got more strong depressions, say southward depressions, like Raghu said, then that would have been a problem for Kerala, as it happened in 2018 when there was massive floods.
But these depressions, I think we also have to add the detail that, as Arindam Chakrabarti from IISc has shown, the depressions are not monolithic. They happen at synoptic time scales, which means 3 to 10 days. And they are in the so-called low frequency, which means at the MISO time scale or the active break time scale. So the general consensus seems to be that there is some debate about this, of course. Generally, the number of monsoon depressions has reduced, and they add about 50% of the seasonal rainfall. But the synoptic systems have increased. And that is consistent with what you would expect in terms of increased extremes. Extremes are fast time scale, multi-day processes. They don't last for weeks like active break periods. So the increased synoptic depressions or 3 to 10 day time scale depressions are increasing the extremes. So the comment that heavy depressions have not occurred is consistent with the general trend. It seems that depressions on lower frequencies are decreasing.
Interesting. So, Raghu, coming back to one of the very frequent questions that we have received from our audience, given all the circumstances, how much rain do you expect in the next 2 months?
Yeah, basically, if normal withdrawal happens, it would happen around 3rd week of September. And the largest variability from year to year also tends to happen in September. So if August holds up to be normal, then it should basically make up for a large part of the deficit that has happened thus far, especially over the West Coast. And if September withdrawal doesn't get pulled into October like it did last year, then you will get near normal rainfall, let's say 900 millimeters for all of India, with 2,500 over the west coast and 1,100 much more over Himalayan foothills and so on. So the crop damage part has to be kept in mind. If things get pulled too far into September, October, then there will be many crop damages. But like last year, coming into early this year, the Rabi crop got a lot of benefits from the excessive rain we had later part of the last monsoon season, which didn't seem to end at all. So the food production in some ways is benefiting by having Rabi production become as large as the Kharif production. But some rain-fed agriculture still suffers because of these patterns of rainfall that are heavy and then dry at the wrong time and so on. So I'm expecting that the IMD forecast will hold true and will mostly end up with a near normal season with plus minus 4-5%.
Okay. Akshay, looking at the trends so far, the central and northwest regions seem to have faced the major brunt of the deficit rainfall. So is this a long-term trend or is this peculiar to the last few years? So what's your opinion on this?
Yeah, so this year quite clearly, if you see 1st June to 4th of August rainfall, so you see those deficiencies building up in some pockets of central India. I think largely central India and some pockets of northwest India. And if you compare, let's say last 6-7 years, so it's quite clear that, let's say Haryana, Chandigarh, Delhi, some parts of Uttar Pradesh, that is Western Uttar Pradesh, some parts of Rajasthan, and I think Eastern Madhya Pradesh. So these subdivisions have consistently received below average rainfall. But when you look at some trends, let's say over latest 35 or 40 years, so it does turn out that these regions are getting reduced rainfall. But when you look at the longer time scale, ever since we have records, so in that particular time scale, it's only the state of Uttar Pradesh that is actually witnessing statistically significant decreasing rainfall. So I would say it's going according to pretty much what we have seen recently. And for central India, I'm not concerned because we do see a couple of monsoon low pressure systems coming up over the next few days. So that should help in bringing more rainfall and making up deficit. But I don't expect these systems to be that strong enough to go and benefit Haryana, Chandigarh, Delhi, Punjab as well. So yes, that's something interesting, I would say.
Drawing from Akshay's answer, Raghu, can you briefly discuss how climate change has played a role in affecting rainfall distribution across monsoon months, especially in India?
Great. Yeah. So I would think of it as a system. So we talk about onset, we talk about withdrawal, talk about active break as if they're all different. But actually onset happens, withdrawal happens, that gives you kind of the length of the rainy season. Within that, you have active periods and break periods, so you get number of rainy days. So you have a distribution of rain between the onset and withdrawal. The work we published back in 2015, for example, shows that since about 1970s, when there was a large-scale climate shift, global climate shift, the onset has been occurring a little bit later than normal. And in general, little bit later means there tends to be lesser seasonal rainfall, which is consistent with a decreasing monsoon trend. And the withdrawal was happening slightly earlier since the mid-70s at the same time, but last year kind of went too far. So we don't know whether that's changing or whether last year was an aberration. We'll see this year. So if you have a later onset of monsoon and an earlier withdrawal, then you're squeezing the season. So depending on how much rainfall you reduce, you may actually increase the intensity of rainfall because you have now fewer days of rain in the season. Length of the rainy season is being squeezed. Climate change, we know that ocean warming and these northward propagating systems and the land-ocean contrast can actually control the onset and the withdrawal and so on. What is interesting there is that the pollution actually is blocking the sunlight over land. So the land is not warming as much as it should. That is part of the reason why you have a weaker circulation and a weaker monsoon. And that is not directly global warming, but pollution is part of the human activity. So that is affecting in that sense. And the question is, if you reduce pollution, what happens? Typically, we said monsoon will recover. But this year gave us a very good example of large-scale pollution reduction because of the lockdowns. And we saw that large-scale adjustment of the dynamic circulation actually cooled part of India. So will reduced pollution actually warm India and give us more monsoon? We are not quite sure yet. But what is, I think the bad news is that with the warming, even if monsoon recovers, let's say from 870 or whatever it has gone down to back to 900 or even more, the extreme events are not going away. This is what we have to plan for. So for a farmer, this means the crop calendar as we think of maybe just something we have to change or throw away, because the onset and the withdrawal are not happening the way they would expect. Plus, you have to worry about crop damage and so on, heavy rainfalls instead of a good smooth distribution. And doing things like forestation, agroforestry, other things to reduce damage, reduce floods could be useful. But if ocean warming is pumping in more moisture and warming over Afghanistan and Pakistan is creating the cyclonic systems that can help pump in moisture from the Arabian Sea into the Indian monsoon region, then we don't have a lot of control on what happens outside. So in that sense, the monsoon response to global warming is quite complicated. My hope is that we will understand better the relation between the change in the onset, the change in the active break cycles, and the speed of propagation of the so-called MISOs or the monsoon intra-seasonal oscillations and the withdrawal. If these are kind of responding to a large-scale dynamic system that is linked, then our chance of improving predictions and projections will improve. But if they're all responding to very different processes, then we are going to have a lot of challenge in trying to improve our predictions of onset and the active breaks and seasonal means, and also projections into the future.
Yeah, and if I can just quickly continue your point, it's really important because if you have, let's say, changes in those onset or arrival as well as withdrawal dates by a few days, then that's fine. But if you have changes of the order of a week or 10 days or even 15 days, then that becomes a big problem, as we are seeing in some parts of Northwest India. And when it comes to applying all this to farmers, it's a big challenge because they are still quite very much to their own traditional cropping calendars. And telling them to really go for a new cropping calendar has its own challenge for the government. So it's definitely important to really see how to convert this science into really some sort of nice application so that it works out quite well.
I think it's important then to add that India's investment of almost 500 crore in the monsoon mission has helped. So if you look at the forecasts at the short, medium time scale of 1 to 3 days, 3 to 10 days, they are very good. And extended range from week 2 to 4, they are kind of useful depending on how farmers are trained to use the probabilistic what if kind of information. And the seasonal forecast, I'm not sure how useful it is to say it will be a normal monsoon, because for a farmer that doesn't mean much, especially when the distribution is so erratic that it is raining heavily in one place, but it is very dry in the next place and so on. So in terms of applications, the so-called sub-seasonal to seasonal timescales or S2S timescale, where India is an active partner in the global efforts, that's where a lot of the decisions get made, whether it's for food or water management or health or energy. I think India is making great progress there. So I have great hope for progress on these fronts.
We do have S2S prediction project, which really is a very promising thing in this new research. So, and I think IITM models are also joining in. So the New Year future is definitely going to be exciting.
Definitely, the progress that India as a country has made, and especially IMD and IITM and many other research institutions, including the IITs, the amount of contribution they have made to the forecasting, weather forecasting in India has been tremendous. Sridhar, if you can put some light on how has been this progress, being someone who is part of the research that IIT does in improving our forecast. So what's your take on this?
Yeah, I think Raghu had already touched upon that a little bit, in the sense that we have to improve our short-term, medium, as well as the long-term predictions. And also on a spatial scale, we have to ensure that the predictive capability is increased. But as we all know, the global models are the bread and butter of forecasting. And basically, these models solve a set of complex mathematical equations for various variables in ocean, atmosphere, and land, such as the moisture, the winds, temperature, and many other variables are solved. And India has invested, in the last decade, it has invested heavily in developing its own model. And I think it is paying a lot of, it is reaping benefits because we have our own model and we can use that model to understand how the monsoon trough moves, the MISO that we call, how it moves. And we can get a good guidance on whether it is going to, on which days it is going to rain, which window is the period for rainfall for central India, and those kind of things. I think we have a good guidance is what we have. And add to that the satellite images and radar images and other tools. They have complemented forecasting in a very nice manner. But even with all these efforts and these advances that we have made, there are still some places, so there are still some inaccuracies, and that is mainly related to the complexities posed by climate change, of course, that Raghu talked in detail. But other than that, they are also there are also process-based deficiencies which we have. So I will just share a screen because I just want to show one or two plots where I'll explain. So basically, what these models do is these models help in understanding the transfer of energy from one place to the other. So it is all the transfer of kinetic or potential energy from one place to the other. And the energy transfer is basically divided by the processes that happen in atmosphere, ocean, and land. And here I have just put, these are not all the processes, these are some of the important processes that govern this energy transfer. And broadly, we can classify them into sub-mesoscale and mesoscale and synoptic scale. And so you have these turbulent processes, you have the gravity waves, you have internal waves, and see eddies, large-scale eddies, and all these things. So the issue is that we don't have very good understanding of these sub-mesoscale processes, which are very small-scale processes which occur in a less than 10 kilometer spatial scale and less than a few hours. So let's say 6 to 7 hours of time scale. We don't have a very good handle on how these processes affect the energy transfer between ocean, atmosphere, and even within ocean and within atmosphere, upper layer and lower layers of atmosphere. That is one of the deficiencies which I think we have to improve to get a good handle on where is the rainfall going to happen, what is the spatial variability of these rainfall events, why is it not raining at one place when it is raining heavily at other place, which is just separated by, let us say, 20 kilometers. One very good example is the July 26, 2005 floods, where Santa Cruz recorded 944 mm, whereas Colaba only recorded 72 mm, which is only 27 kilometers apart. So why are these kind of variabilities happening is something I think we have to figure out using these, by resolving these sub-mesoscale processes. And the other thing is that you have something known as these boundary layer processes, which are highly erratic and highly nonlinear processes, and they occur in the short 1 kilometer atmospheric time scale, both atmospheric space, both in ocean and atmosphere. These boundary layer processes are very common. The issue is that these processes are so nonlinear that we have to use some assumptions to model these processes, and those are the assumptions that go into the models. And those assumptions sometimes work, sometimes they don't work. So that is the other reason. I mean, that is, so again, this comes back to the process dynamics. Our understanding of these processes have to be improved through these monsoon missions programs that Raghu was talking about, and also through some own research that we can do at IIT or other premier institutes. So only when we understand these processes in detail, then we don't have to use any assumptions. We can actually just take that process and put it in the model. Then our predictive capability will increase at spatial scale as well as time scale. On a shorter time scale, we would be able to predict what is happening, and we can improve our short-term forecasting in a much finer manner. Long-term forecasting is a big challenge. I'm not sure how to improve that. Maybe Raghu can shed some light, because that encompasses climate change and land use process and other things. But on a short and medium range, I think if we improve these kind of parameterizations or the sub-meso scale feature resolutions, then I think we have a good chance of improving the monsoon patterns and the rainfall pattern on a spatial scale.
I think, let me jump in there a little bit if you have a minute. You can take down the screen. Basically, I think clear up the misunderstanding. India actually got the models, the coupled forecast system from NOAA, National Oceanic and Atmospheric Administration in the US, and it got the UK Met Office for the weather time scale forecasts. And so India doesn't have its own models. It also runs what is called Weather Research Forecast model, WRF model. So what is great about the investment is that after we got these models, those global centers, whether it's ECMWF, European centers, US centers, they look at the monsoon, but they don't pay attention to the details of land use over India, topography of the Western Ghats, and so on. So what India did was actually fund outsiders. Some 15, 20 projects were funded to US. I had some funds, other people, Norway, Japan, Germany, UK, and so on. So they improved the processes over India. And this also is being done at multiple scales. So the long-term forecast is being done by this coupled forecast system, which is global. And the short-term forecasts are being done by, let's say, WRF for a city scale. So why it rains over Colaba 900 millimeters and somewhere else only 80 millimeters? We know a lot based on modeling that's being done here at IIT Bombay, for example. These are related to the urban heat island effects, and Bombay, you'll be surprised how many mountains there are actually in Bombay. It's not a very flat island. So these create local eddies. If you sit here on Powai Lake, you get these howling winds that are like a wave. Those are created by these local topographies. Plus, there are other interesting things. For example, another paper that a student at IIT Bombay did with me and Subimal Ghosh, it shows that Western Ghats vegetation acts like a moisture capacitor. So during an active period when it is raining over the Western Ghats, the vegetation is soaking up a lot of the rain and the moisture. And when it's a break period, evapotranspiration is actually releasing this moisture. And almost 30% of the summer rainfall over Tamil Nadu is coming from Western Ghats moisture. So Tamil Nadu, you think, doesn't get much rain. Actually, it gets 300 to 350 millimeters of rain in the summer. It gets almost 700 in the northeast monsoon, but 30-40% of that is coming from the moisture capacitor effect of vegetation. So these are kind of multiple scales that are being done at IITM and NCMRWF in Delhi and so on. So the so-called mesoscale modeling at kilometer scale has to improve, has to be done more. So all the process understanding exists. People are working on these processes. So it's not limited in terms of understanding, but you need more observations. You need data assimilation to improve the initialization of the forecast and so on. So I think India has multiple investments in multiple centers, but institutes like IIT, IISc, ICERS have to work with these centers and trains the workforce and the students to improve these forecasts at various time scales.
Definitely.
Quickly take a minute, because this is really interesting and very correct in terms of all scientific collaborations. There is one more part which we often have to really think about, which is in terms of dissemination of forecasts. Let's say if you have got a forecast which is correct, but as long as it is not properly communicated to people, it might not be of that great help. And that has been a big problem. So like we were discussing about farmers and things about onset and withdrawal, but the reality is that not more than 50% farmers in any state of the country actually get text messages from the central government or the state government. They have something called as M-Kisan portal, from where they send text messages to farmers informing about weather. So if you look at key states, Uttar Pradesh 37%, Maharashtra 26%, Punjab just 21%. So we need to really also enhance our efforts in terms of disseminating this weather forecast, so that it really produces a comprehensive effect. Like we get a correct forecast, and you also have people who are weather ready.
That also
just,
depends on how exposed they are. If you look at the US and the West, for example, weather forecast has been going on for many decades. People wake up and they look at forecasts and decide how to dress, whether to carry an umbrella. In India, we are not used to it. So we have to get used to it over the years that weather forecasts are being made and they're reliable and so on.
And we also need to start doing hourly forecast. I know it's really difficult, but that is very important for Mumbai, simply from seeing what has been happening recently. Because if it is just going to rain in some part of the day, not throughout the day, people have to really plan doing their stuff at those times. I mean, here in the UK, if we know that it's going to rain in the afternoon, we just do our stuff in the morning. I know it's difficult for India. You have differences between mid-latitudes, high latitudes, and tropics, but let's see what happens.
Yeah, that's a big difference. Mid-latitudes, you have 1,000-kilometer systems that last for 10 days, whereas in the tropics, things fire up in minutes.
Yeah, that's why I was talking about these very small scale and very small spatial scale and time scale processes, which by the time you forecast, they are gone and they have already done the damage in terms of heavy rains or thunderstorms. So those are the things that we need to kind of buckle up, and which is, I think, in process. There are a lot of studies and there are a lot of research grants that are being provided for doing those kind of research.
Great. I think the message is clear that the weather system, the monsoon system, and across India, the entire weather system is very complex. At the same time, our ability to forecast and understand these systems has been improving and will definitely improve exponentially in future. At the same time, we as citizens, it becomes our duty to understand these things and inculcate a habit of following weather and teaching that to our fellow citizens, so that the overall awareness on weather improves as a country in India. So to wrap up, we are running out of time. So just one word answer from all of you. If you have to put a figure, I know this is not a easy task to do, and it's not very useful for many of the farmers who look forward to it. But however, this is kind of a monsoon gamble that every meteorologist play, putting a number on the overall monsoon rainfall. So what is your take? How much is against the long period average? How much would India receive at the end of September?
I think IMD is right, but as I said, the distribution is more important. So you will be within plus minus 5%, I think, this year.
Yeah, so I agree. 100 to 105 of LPA is what is expected. So I also go with IMD and their forecast.
Sounds like an election debate. So I would say 102. I would say 100 plus minus 10, because that's always going to happen. Anyway, jokes apart, it should be 102 in my opinion. But like Raghu said, distribution matters the most, because farmers, for them, it needs to rain in their area, not somewhere else.
Yes, definitely. The IMD prediction says it's 104% now. And definitely we are looking at a better August and slightly better than normal September to make up for the deficit that we saw in June and July. So overall, there could be a few more intense monsoon spells. So stay safe and enjoy the unparalleled gift of nature that India has, the monsoon 2020 and the monsoon that are coming up. So thank you very much for all the experts who joined us. And this was a very engaging discussion on monsoon. Thank you so much for this.
Thank you, Vikshit. Bye-bye.
Thank you so much. And thank you, Raghu and Akshay.
Thank you, everyone who has joined us. Stay tuned to the Weather Channel. Thank you.